Hi, everyone. My name is Spoons. I'm a co-founder and the chief architect at Lightstep. Welcome to SLOconf. I'm an engineer by training, and I've created Pager for many years. So before I was a co-founder, I was at Google doing all kinds of infrastructure and at Lightstep, I also spend a lot of time with our platform and SRE teams thinking about building and operating services and how we measure service quality. And of course, I also think a lot about observability. So today I'm going to talk about using observability to set good SLOs. Okay, setting SLOs. Let me just talk about that first. So if someone were to ask me to set an SLO for my service, especially if I had users outside of my organization, so what I think of as an external SLO, I would probably look to see if there's anything written down, right? I would look to see if we had something in our terms of service, or maybe we had an SLA. Those could be things that used to inform an SLO. Or if we didn't have those, then maybe I would ask my users, right? And see if I could get them on the phone or talk to them. Or if I couldn't talk to them, then think about how I could measure their expectations in some other way. Do they behave differently when they get different levels of service? And while I think that's a super fun problem, that's not really what I'm here to talk about today. What I want to talk about is actually internal SLOs. So this is the case where my service is not used by anyone outside of my organization. It's just other services inside of my organization. So my customers are my coworkers. And I actually, at least in what I've seen, these internal services often form the majority of services within an organization. So I think thinking about those SLOs is pretty important. So why don't we just get those people on the phone? Well, maybe the first problem is I don't know who to call. I don't actually know who depends on my service. And maybe that's too hard. So maybe we should just start with something simpler. I can look at the performance that my service is offering today and go look at my metrics dashboard. And, maybe I can just draw a line like this. And I'm sure you're all shaking your heads like that's not how you make an SLO. Of course, you want to look at your current performance and use that as one of the things that you're thinking about when setting an SLO. But you really want to understand what your users expect and what those other services within your organization need in order for them to hit their own SLOs, right? So how can observability help? Let me take a minute and define observability. So I guess I think of observability having two parts. One of those is something that I think everybody does pretty much these days and has done for a long time, which is to monitor the health of their systems, either both the infrastructure, the databases, the VMs, and the application services themselves. And this is monitoring, right? The other half of observability, I think, which is something that has changed a lot more recently, and that I think we think about in different ways, is how we understand and forecast changes in that health. So to give an example, if the latency of my service changes, if the health of my service changes, how does that affect the health of other services? And that should sound familiar. That's really the exercise that we're going through here and trying to build an SLO. And I know a lot of people think about observability in terms of these three pillars: metrics, logs, and traces. But I really want to dissuade people from thinking about these as the definition of observability, because just because you have metrics, logs, and traces doesn't mean that you have observability. These are really just three different kinds of telemetry, three kinds of data. It's really what you do with that data that matters. Okay, so speaking of those three kinds of telemetry, I want to spend just a couple minutes making sure that we're all on the same page about distributed traces, because I think everyone's pretty familiar with metrics and logs, but I'm going to talk a bunch about traces, so I want to spend a minute on that. Okay, if you've used a distributed tracing tool, then you might have seen something that looks like this or like one of these. When you look at a trace, they all show something that's kind of similar. It looks a little bit like a Gantt chart. You have time going from left to right usually, and as you go from the top to the bottom, you're going sort of deeper down your stack. If I kind of pull one of those and make sort of an idealized version, it might look something like this. That is, a trace shows in these colored boxes the time that each of these different services is processing parts of a request. And in the end, traces are just kind of a kind of structured logging, right? Like you can think of each of these colored bars as, maybe a pair of logging statements that tell you when the beginning and end of request is. But the structure here is really important because not only do you know the beginning and end, you also know the interactions between these services, right? You know where one service calls another, and you know when those services return control back to the services higher up the stack. And if you know those interactions, then you know where responsibility for handling a request begins and ends when it's handed off to another service, and you know how to attribute failures. And importantly, you know what services you depend on and what services depend on you. And that really was the question that we were trying to answer here, right? I just want to say a couple more things about traces before we get back to talking about SLOs. And really, this whole talk is kind of an example of this first statement here, that traces, and you could just put metrics or you could put logs in here as well. Those are the raw material, right? That's not the value that you get. It's not the finished product. It's really what you do with that raw data where you get the value. So you can think of traces just as that kind of struct, right? It's just a data type. And again, the same thing for metrics and logs. And once you've chosen that data type, that has a bunch of impact on the performance of storage and analytics systems and things like that. But again, if you go to the use cases, like what are you actually using this stuff for? That's what's really important. And I think, maybe you or someone in your organization has looked at one of these traces as part of maybe responding to an incident, trying to find contributing factors. But if you take one thing from this talk, and it's that you should really separate out the concept of that raw material from the value that it can provide. If you want to know more about tracing, including a bunch of examples of the other kinds of analyses you can do with traces, you should check out the Dapper paper. It's a paper one of my co-founders wrote and with a bunch of other folks at Google. It describes Google's internal distributed tracing system, but a bunch of open source work that's been done since is very closely related. So it's also pretty informative on that front. And I'd be remiss if I also didn't mention a book that I helped write on distributed tracing, and one of the things that we talk about in there is how to get value from tracing. Okay, so remember, telemetry is the raw material, not the finished product. Let's talk about a product that we can build using that raw material. Let's talk about deriving internal SLOs using that tracing data. So I'm going to kind of work through an example here, and the idea is that you and I, we work on this blue service here, and I'm going to fill in a bunch of the picture around this, but we're trying to figure out an SLO for our service. Now, one of the things we did is we collected some of these distributed traces, and not only did we look at them, we also used them to learn that this other service, the yellow service, actually depends on our service. And this, it turns out, is a user-facing service. So they've actually already gone through the exercise of figuring out what their SLO needs to be. And again, I'm oversimplifying a lot of things here, but let's just, for the sake of argument, say that they've determined that their SLO for latency means that they need to achieve a 99th percentile needs to be less than 5 seconds. Now, like I said, we looked at some traces to try and understand this. And this is, again, just maybe an oversimplified version, but let's say one trace that we looked at to try and understand what our SLO for the blue service is supposed to be. And you can see in the trace here, actually, most of the time that the yellow service is processing this request, it's actually waiting on us, which is good for us because that means that we can spend most of that SLO's budget in a way, right? We can actually write an SLO for our own service that's pretty similar to that. And I'm cheating a little bit here. I probably should leave a little bit of buffer on either side, but you get the idea that like our SLO is going to be pretty similar to theirs. And so for the example, I'm just writing 99th percentile latency has to be less than 5 seconds. Now, we can go one step further now. We've set our own SLO, but for us to feel good about being able to meet that, we need to map our dependencies and understand the SLOs of those other services, right? So from this trace, we learned actually that in this kind of request, we actually depend on this pink service further down the stack. And what's interesting here is that we actually, in this trace, made 2 sequential calls to the pink service. And that means, even though we've got sort of this, think of it like a 5-second budget to process these requests, those 2 things actually have to happen in half the time, right? So maybe first pass on this is that we think that the pink service needs to have a 99th percentile latency that's less than 2.5 seconds. It's actually a little more subtle than that because we're not talking about all of the requests being faster than 2.5 seconds so that we can make all of our requests faster than 5 seconds. There's going to be some cases where the pink service doesn't meet that. And in fact, when there's 2 requests that we make as part of each of the requests to our blue service, that's 2 opportunities for the pink service to fail to meet that. So we actually need the pink service to hold to an even tighter, sort of a tighter bound. They actually need their 99.5th percentile latency to be less than 2.5 seconds. There's other ways you can actually work it up, but this is one example of that. And I guess really what I want to call out here is that we had to figure out what these dependencies were. Traces helped us do that. But we also needed to know the way that we depended on them, right? The fact that we make multiple calls is really important to this. The last thing I wanted to call out here is, say we also, through some other means, learned that we depend on this gray service here. But what's important from this example is that this trace actually doesn't help us understand what's going on there, right? This is the gray service actually doesn't participate in these requests. So if we want to figure out what the SLO for the gray service is and help that team to set that goal for themselves, these requests are not going to help us do that. Okay, so hopefully that was a useful example. So I just want to leave you with a couple other things. We talk a lot about observability tools, but I really wanted to ask all of you to think more about observability as a tool. That is, right, not just like, how do I get the latest, fanciest, metrics dashboard or something like that, but how do I use this data, this telemetry like metrics, logs, and traces to measure and understand service health? Because ultimately SLOs are about using data to communicate and make better decisions. Observability is really a key part of measuring and understanding a lot of that data. And again, different kinds of telemetry, not just metrics, traces have a pretty important role to play here, especially when you're thinking about dependencies and setting these internal SLOs. All right, with that, thanks for your attention. If you want to hear more from me, you can follow me on Twitter at save_spoons. And if you want to learn more about observability, please check out Lightstep. Thanks.